myself over the key concepts. But I really want to talk about the negative indices because I can sense that yesterday after the lesson, we're still not very strong in our negative indices. Okay? Especially when it comes to something like that, okay, which I have summarized over here. But 1 over a to the power of negative n. Okay, why is it that it is equals to a to the power of n? Okay, why is it that I conclude that it is about moving along the fraction itself? Okay, yesterday I said this many times already. This can be expressed as this, for which we do the complete change. Okay, sorry. Okay, a to the power negative n, we write it as 1 over a to the power n. Okay, then because it's dividing by a fraction, we can write it this way and hence we write it like that. Okay, likewise, when it is a to the power of negative n itself, we have established the understanding that it is the same as 1 over a to the power n. Okay, so it is about moving something along the fraction. That is how I see it. Okay, when we apply the negative. So once we apply the negative, once we have shifted it, okay, the negative sign disappears. It doesn't become a problem anymore. Okay, so we look at one more example. Okay, we look at this one. 18g to the power negative 6 divided by 3, g to the power negative 2, then after that square it again. Okay? Usually we express things in fractional form rather than to use the division sign. Okay, so you may express it into this manner, which will facilitate your understanding of negative, or your application of negative powers. Before we do any shifting, we will first handle this g to the power negative 2 followed by a square first, for which I can apply my law number 3 and get g to the power of negative 4. Okay? Then, keeping in mind that our negative power, okay, the negative 6 is only for this g, this negative 4 is only for this g, so only the g is the one that moves. So being able to recognize the correct base for that power is important. Okay, sorry. Negative 6, yeah. Okay, so the g to the power negative 6 comes down, so we are having it as g to the power 6, and then g to the power negative 4 goes up, that will become g to the power 4. Okay, then now we can simplify. 18 divided by 3, that will give us 6. Okay, g to the power 4 and g to the power 6, we are actually left with a g to the power 2. Okay, yes. Why does the negative become positive? Because we already applied it. We shifted it already, it should disappear. Yeah? We have established this fact. Is there a negative sign over here? No, because I already applied it. Okay. Yesterday I talked about having a power in our inventory. So after I apply the power, it loses, it disappears in our inventory already. Okay. So we apply already, no more. The negative sign, no more. Right? It cannot still be there, what? You shift from the numerator to the denominator. Why is it that the power, negative power will still exist? How can they be equal? Why do they shift? I explain it here, no? Yeah. Do you not recognize a power n is the same as a power n over 1? So from the denominator, it became onto the numerator. Separate the fraction. Separate what fraction? What do you mean by separate? You really want to see me after class, okay? So that we can understand what's going on. Right? Anybody else having the same problem? Yes, Jaden. Or why the negative sign disappear? Because I already shifted. So your g to the power negative 4 already shifted up. This thing shift up already, negative sign must disappear. Because the negative sign, I must have it in positive numbers. Okay, maybe I don't have it in G because G maybe you see too many G's, you get yourself confused. Maybe let me just change it X. Okay, they're separate things. They're separate things. Okay. So down here X. The 18 don't have the negative sign.
So previously your 18 G.
It is G to the power of negative 6. 18 is itself. The negative doesn't apply to the 18. Yesterday, which one is it? Part B. Yesterday we did this, okay, and then first we bring in the power, so 2 cube will be 8, d is now negative 3, d cube. It is only the d that moves, okay, d negative 2 comes down, d from negative 3 goes up. This is what I wrote yesterday. Okay, and then simplify. We are going to simplify it. 16 divided by 8 is 2. Okay, then after that d over here is e squared. This was what we did yesterday, yes. Sorry, because I changed the question just now. So if it's like that, it's straight. Okay, I changed back to the original question. Okay, this is the original. Okay? Yes. Because the question says simplify to positive index form. Your powers, your index must be positive numbers. That's why you must apply and change the negative sign once you move it in the fraction. Once you apply the negative, it stops there already. Yeah. If you want to shift this g to the power 4 down, it must become g to the power of negative 4. Yeah. You need to express it in the fraction eventually. You cannot have it in the division form because it is not helpful at all. Yeah. You cannot. Like that is not simplified, no? Yeah. And now even if I do it division, it will look like that. But I think in this form it's not helpful. Okay, because it's not intuitive. Alright? I'm sorry, I'm very baffled by this because this is my first time encountering problems with negative indices. Okay? Yes. Alright? Maybe we do one more. Okay, we do one more. You create the question yourself. Okay? You create the question yourself. Okay, we do it. Alright? Tell me what's in the numerator. Okay? Give me anything. Anybody give me something? 5. Then xy power 10. Okay? We don't do square root first. Okay? This is rational index. Alright? Anything else? Denominator? Anything? 13. Okay? Then after that what? X to the power of? Can we don't do positive integers because we're trying to handle negative integers now? Negative 3, okay? Y to the power of? we just keep it as power 1. Okay, so now how to simplify this? Okay, it is very important that we are able to recognize the correct base for the power. There are no brackets over here. Okay, 5 is itself times x to the power of 1. Okay, and then y to the power of 10. Okay, so power for the base, power for the base. This number here has no power. Okay, in fact, it's just 1. Okay, we don't usually write powers of 1. Right? This 13 also power of 1. X from -3, y to the power of 7. Separate components. We must see all these things separately. Okay, then now, okay, we apply and try to simplify this question. Alright, so this x power -3, we need to make it into a positive index form and its equivalence. Okay, what it is equal to is that it is as good as having it sit on top of the fraction. Okay, so I shifted the x to the power -3 on top and that will become a x to the power 3. And then after that 13, y to the power 7. Because only this thing had a negative index. Okay, negative power, for which I shifted it up already. Now I need to continue simplifying it. X to the power 1 times x to the power 3, that will give us x to the power 4. Okay, y to the power 10 divided by y to the power 7, that will simplify to a y to the power 3. And this will be the answer. Can you get it now?
Yes.
Okay, need another one more?
Yes.
Yes? No, no square root later. Okay, we do question 2 or break this down in. Okay, simplify this one. We always must know that Commons rule apply. 2 brackets first, then multiplication and division, then addition and subtraction. So there is a division here, okay, between 6h squared divided by 2h to the power -2. So it will be helpful for us to write it in this manner. Right? Then minus away, we can do this multiplication first. H times h cubed, that will give us h to the power 4. Okay? Followed by minus away 4 over h to the power -4. Okay? Any questions at this juncture? Alright? Yes, Yola. How do I get h to the power 4? This is h to the power 1 times h to the power 3. For which I apply this law, my powers add up. Okay, so get 4. Alright? Next. Okay? We handle the negative powers. This h to the power -2, what happens to it? Or rather this expression here, what will happen to it? Maybe Mel, you want to try? So what do I write? 6h squared is original, yes, then. Times, for which I don't need to write another, I don't need intention write times. H to the power 2, right? So this h squared, h to the power -2, here, this thing has shifted up into the numerator. So what's left in the denominator is a, okay? Isn't it already down? Your fraction got how many layers? Not kueh lapis, you know. Only 2 layers, right? So only top layer and bottom layer. It's already at bottom, no basement. Okay? Why? Because is there a negative sign here?
So you only like switch
No, because my power here, what is the base for this power? H. Okay, 2 over here is the power of 1. Alright? Okay, minus away H to the power 4. Then after the second one, okay, Jaden, give me what do I write here for this part? 4 over H to the power negative 4. What does it become? So what do I write? 4 H to the power 4. Okay? Yes. Right? 6 divided by 2, that gives us 3. H squared times H squared, that will give us H power 4. Okay? They're all like terms. They're all H to the power 4s. So we just simplify 3 minus 1 minus 4. Okay? So that will give us negative 2 H to the power 4. Still need to shift anything? Don't need. This one is a negative 2, not power. Okay? So it ends here. Alright? Okay? Are we ready to move on?
Yeah.
Okay? We move on to rational index now. Okay? Don't make me very anxious to teach you rational index now. After negative index. Okay? What do I want to say? Okay, so rational index, what does it mean? It means that we're trying to see what if the power, okay, here is a rational number. What is a rational number? Does anyone remember that? What is rational? Okay, a rational number is a number that can be expressed as a fraction. Okay, for example, give me some examples. The number. 1 over 4. 3 over 2. Okay, now is the whole number like 3 a rational number? Yes. Okay, because it is 3 over 1. Right? What about square root 4? Is it a rational number? Yes, because square root 4 is simplified to 2. Okay? So 0.3. Is it a rational number? Yes, because it is 3 over 10. Okay? 0.3 recurring. Is it a rational number? Yes, because it is 1/3. Okay? Right, so all these numbers are considered rational numbers. Okay, what is the opposite of rational number? Irrational. Okay, and what is an irrational number then? Okay, numbers like pi. Okay, later on we'll also be looking at numbers like e. Okay, e is considered as an exponential number. Okay, so otherwise, okay, numbers such as square root 7, okay, is also an irrational number. Okay, for example, pi e square root 7. Okay, they are numbers that cannot be expressed as a fraction. Okay, so even if maybe just to also add on to this list, even if you get a decimal like 5, 3, 4, 1, 6, it is also a rational number. Okay, because I can write it as a fraction. Okay, it will just be 5, 3, 4, 1, 6 divided by 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, right? I can write it as a fraction. Okay, so just want to be clear about what is a rational number first. Right? We have not yet touched on the main concept. Okay, we are trying to see what happens when my power is a rational number. Okay, in other words, I'm looking at a to the power of m over n. Okay, whereby m and n are integers, this m over n is a rational number. Okay, because we understand that rational number is actually a number that can express as a fraction. Okay, so we know since sec 1 the idea of square root and cube root, we know that 3 squared is 3 times 3, which is equals to 9. And then we have the positive square root, okay, of 9. When I say positive square root of 9, we are writing it in symbolic form as square root 9, which is equals to 3. Okay, so this sign itself refers to the positive square root, right? But of course we know that, okay, if I give you x squared equals to 9, x itself can be both positive 3 or negative 3. But that is not our objective over here. We're trying to understand the positive square root first. Okay? Then we also have our cube root, which is 27. And when we say positive cube root of 27, I will write it this way, okay, for which I get cube root of 27 to be equals to 3. Okay, I'll erase this part now. And then, okay, by extension of this idea, okay, 3 to the power 4 is 3 times 3 times 3 times 3, which is actually going to give us 81. For which, if I want to take the positive fourth root to get back the original base of 3, okay, we will say that it's a positive fourth root, because we must have something that goes beyond just cube root. Okay, so square root, cube root, the next one is called fourth. Okay, there of course we have fifth root, sixth root, and then all the way to nth root down. Okay, in a very generic manner. So how do we write the fourth root? We will write it in this manner. Okay, so we understand that our square root, cube root, they are the opposite of our squares and cubes. So likewise, okay, the fourth root will have to be opposite of the power of 4. Okay, for which we will usually write it this way, and it should give us 3 because it's opposite. Right? So, in other words, if I have b to the power of n to be equals to a, okay, I will be able to say that the nth root of a opposite will be equals to b. Okay, and this idea of the nth root, okay, it must be a positive nth root. Okay, so what I'm trying to develop over here is that we must know this sign itself is the positive root sign. Okay, what number is it? Okay, it's dependent on what you see over here. So this is the positive nth root. Over here I have the positive fourth root, positive cube root, and then the positive square root. For square root, we don't need to write down the square. We don't need to write down the 2. Okay, but cube root and beyond, we need to put in the number. The number needs to be small. You cannot write it as equally large, okay, as a number, because this will then mean 3 times square root 27. Alright? If you want to refer to the positive cube root of 27, okay, it needs to be written as a small 3. Okay? Right? Questions? Understand this concept, huh? Okay. Okay, what is 5 to the power 1/3 equal to? Okay? Because you're trying to see what is the power is a fraction, right? You want to know what does this equal to. Let's pick this figure up. Okay, so let's say I don't know what is it. I let P to be equals to 5 to the power 1/3. I want to know what is P lah. Okay? I know some skills in indices already. Right? Okay? I can first find out what is P cube. Okay? If I do P cube, that means my 5 to the power 1/3, I also need to cube it. Agree with this so far?
Yes.
Okay? So what is 5 to the power 1/3 cube? Based on our laws, okay, our 1/3 times 3, that will give us a power of 1. Okay? Because 1/3 times 3. Which is 5 now. Okay? So, if I want to find the value of P, okay, I know that it is actually the reverse of what we were doing earlier on. So it is the cube root of 5. Alright? Because just now earlier on, okay, if I say 3 to the power 4 equals 81, the 4th root opposite, okay, will give us 3. So now I'm saying that P cube is equals to 5. Okay, if I want to know what is P, right, I'm going to do the cube root of 5. Okay, and that will give me P. But I know that P was defined to be 5 to the power 1/3. That's why 5 to the power 1/3 is the positive cube root of 5. Okay? So that is the key concept that we want to take away when we're dealing with rational index. Okay? I'm trying to find out what is the value of 5 to the power 1/3. I'll leave it here for a moment for you to understand what's going on first before I draw the conclusion. Okay, with that, I'm trying to say that when I write something a to the power 1 over n, it is the n root of a. To give a few examples to illustrate this, if I'm trying to say a to the power half, it means the square root of a. If I'm trying to say a to the power 1/3, it means the cube root of a. If I'm trying to see a to the power 1 over 1000, it means that it is the 1000 root of a. Okay? They are equal, they are equivalent. Okay? So, earlier on when we look at negative index, once we exhaust the negative power, it means that it has shifted its position in the fraction. Now, if I have exhausted the denominator of the power, it means that it becomes a radical sign, it becomes a root. Okay? Whatever root, whatever power number it is. Right? So when our powers are expressed as a fraction, I want us to see it separately, numerator and denominator separately. Okay? No. Alright? We get this so far? Garrett, I said no. I said no. No. I said no. Okay? You might be wondering at this juncture, then what is a to the power of maybe 2 over 3? Because over here, my numerators are all 1. What if my numerator is not 1? Okay? I want us to see it in this manner. Okay? That 2/3 is actually equals to 1/3 times 2. Okay? Which we know that it is a to the power 1/3. And then after that square. Right? So see the numerator and the denominator separately. The numerator is trying to apply like what we were doing earlier on. Okay? But the denominator is trying to give us a root. Okay? So see the numerator and denominator separately. So that's the thing about indices. We need to see things as separate parts, separate components. Be able to identify the correct bases to the powers. Okay? And then in this case, for power, numerator and denominator separately. Okay? Yeah, then the 2 will go in now, but this one is no effect. So if I were to give you a numeric example, let's say I give you 8 to the power 2/3. Okay, how will it look like? It will mean that it is 8 to the power 1/3 followed by a square. 8 to the power 1/3 is actually 2. That's the cube root of 8. Okay, for which later on I square it, and hence my answer is 4. Okay? Questions? Right? In my process over here, I'm trying to explain why is it that 5 to the power 1/3 is equal to cube root of 5. Okay, for which we generate this one. Okay, we can do it multiple times, it will give this to us all the time. Okay, for which we will now learn how to apply it. Questions? Okay. Do another one. What if we have, okay, let's show a lot of things that we already know together so far. 32 to the power of negative 3/5. Okay, we need to see this separately. We have the negative sign, we have the numerator, we have the denominator. Okay, which one do you want to go first? Negative, numerator, or denominator? Numerator. Okay, if you want to do the numerator first, we are trying to deal with it this way. Okay, we are dealing with 3 times negative 1/5 is the same as negative 3/5. So Moses says do a numerator first, so 32 cube. Okay? Yes. We're just doing with what Moses has decided with us. Okay, there's alternatives to do this. So 32 cube is actually equals to 32768. Okay. And after to the power negative 1/5. Right? What do you want to do next? So we'll start with the numerator portion. Okay, we still have the negative sign as well as the denominator. Okay, what do you want to do next? You want to do negative first? Or the denominator first? It doesn't matter. We do a negative, okay? So the negative will tell us that it shifts in the fraction, right? In this case, how does it look like as a fraction? It is a whole number. Okay, so actually it is over 1. So it goes down into the denominator. We are looking at 1/32. 32768. So the negative is resolved already. I'm left with a power of 1/5. Okay? For which I'm looking at the 5th root of 1 and the 5th root of 32768. The 5th root of 1 is just 1. You root any 1, okay, whichever root is it will just be 1. Okay, and then 32768. Pressing it into your calculator. Do you know how to press the 5th root in your calculator? Okay, where? In your calculator, can you find that? Okay, some of your calculator models, they do have it. Otherwise, you just put 32768 to the power 1/5. They will also give you the same answer. Okay, so either you write it this way or you write it as 32768 to the power 1/5. You will also be able to get an answer of 1/8. Okay? So, in this set of working, we started with handling the numerator first. Okay, and then just now I think Jaden said you want to start with what again? Negative power.
You mean 1/5, like power to 1/5, then bracket and power to 1/5.
Yes, okay. So you can do this as well. 32 to the power 1/5 might be easier to mentally calculate if you are familiar with your powers of 2. Okay, that will be equals to 2. Right? Sorry, I'm wrong. It's 2. Okay? So 2 to the power negative 3 even easier to calculate, right? This is actually 1 over 2 cubed, which is 1 over 8. Okay? So I'm seeing things in separate components. Negative has a certain effect, numerator has a different effect, okay, denominator has a different effect. The numerator is about repeated multiplication, okay, for which you can just press calculator to make it if it's a number. Okay? Let's look at what if. So I've been doing practice now 11 by the way. Okay. Part C. What if we have 100 to the power 1.5? What is 1.5 as a fraction? 1.5 out of 10. What is 1.5 as a fraction? 3 over 2. Okay. If you don't know how to change decimal to fraction, may I suggest use calculator. You just press 1.5, then press the magic button to change it into a fraction. Okay. So 1.5 is 3 over 2. Okay. For which we see numerator and denominator separately. Okay. So you can do 100 to the power half first, followed by a cube. So to the power of half means square root of 100. And that's 10, so 10 cube, 1000. Okay? You can definitely do 100 to the power 3 first. Then after that, square root. That's fine. But you end up getting very large numbers. Okay? Okay, let's do this last one for the day. 4 to the power of 2.5 plus 27 to the power of 4 over 3. Okay, 2.5, what is it as a fraction? 5 over 2. 27 to the power of 5 over 3, we have no change to that. Okay. So, it's really dependent on yourself in your mental calculation. Okay, although this question says without using a calculator, what you will choose to do. So I will choose to do the square root first. Okay, so 4 to the power of half is 2. And then 27 to the power of 4 over 3, I will actually choose to do the cube root first. Because I know 27 to the power 1/3 is 3. 2 to the power of 5 is 32. 3 to the power of 4 is 9 times 9, 81. Why would I say 9 times 9? Because 3 to the power of 4 is 3 squared times 3 squared. Okay? So that is 9 times 9. So it's not like I've got magical powers that can do mental sums very clearly, very quickly. Okay? It's just a strategy on how do you break it down. Okay? So 2 to the power of 5, I will tend to think of 2 squared times 2 squared times 2. So 2 squared is 4, 4 times 4, that's 16, 16 times another 2, 32. Okay? Right, so we get about 1/3. Okay? And why is it that I could do that kind of mental calculation so quickly? It's because I'm familiar with my next movie as well. Okay, so we have covered all 8 key concepts of your indices already, whereby the 8th one, okay, is about our denominator of the power. Okay, so exercise 3A for your homework. Okay, please get it done by tomorrow, not possible, right? Okay, I'll just have it due on Monday. Okay, tomorrow I will give your rational indices homework like this, so it will add up. Okay, so this will be due Monday. You'll come back from camp on Saturday, or Monday is not school. How much?